Hello guys, uh, very good morning. Today we are going to discuss about physical science subject that we are going to deal with the first chapter, that is reflection of light at curved surface. Before going into the chapter, let us understand what is reflection. What is reflection? Let me take a plane surface, which is a transparent surface. When I send a light through this a glass, what will happen? The light will penetrate through this glass surface. But what I will do is, what I will do, I will coat this glass surface. I will coat this glass surface with some reflecting paint, which we call it as opaque. If what is this opaque? Opaque is after painting it after what is this opaque? Opaque is nothing but a reflecting surface. When I incident a light, the light will get reflected back to the same medium, that is called reflection. It will not penetrate through the surface, that is called reflection. Is it clear? There are two laws of reflection. These laws of reflection are applied for the plane mirrors as well as the curved mirrors. Let me apply it for a plane mirror. Let us take this is an incident light ray. What is this? This is an incident light ray. This is a incident light ray. When an incident light ray, this is incident light ray, this is a reflected light ray. What is this? This is a normal. This dotted line is a normal. When a light is incident, making an angle theta 1 with respect to the normal, the reflected ray will, this incident ray will get reflected back, passing through the, making an angle with the normal. That angle is theta. Theta. What is this first law is saying about? This first law is the incident angle theta and the reflected angle theta both are same, equal. Similarly here, this is an incident light ray, this is a reflected light ray. If it is making theta 1 here, it will make theta 2 here. That means according to the first law of reflection, theta 1 equals to theta 2. What the second law of reflection? The incident light ray, reflected light ray and the normal. All of them are in the same plane or not? If this is plane P1, if this is plane P2, all of them are same plane. Similarly, here the incident light ray, the reflected light ray. What is the normal here? From C to P. This is a normal. This is an imaginary line. What is this C, P, and F? We will discuss all of them in detail. Let me explain. So these two laws of reflection is clear. How the second question is how the curved surface, reflecting curved surface is made. Mirrors are made. So here there are two mirrors, concave mirror and convex mirror. So here if I incident light like this, I can see a cave like structure. So it is called concave mirror. But here I should incident a light like this. This is a opaque side. So it is a convex mirror. What is convex mirror? It is bulged out. What is concave mirror? It is bulged inside. Here. So here, this is what? Center of curvature. This is pole. This is focus. What is a pole? Geometrical center of the mirror is called pole. What is center of curvature? Center of curvature is this. The center of the sphere. What is this focus? The focus is a midpoint of F and P and F. Focus is a light. For example, when a light is incident parallel, when a number of lights are incident parallel to the principal axis, all these lights will converge. When the light is coming from the infinite, all these lights will converge at that point that is called focus, where you get a clear image. This is clear? Okay. What is this principal axis? Principal axis is an imaginary line. Imaginary line. Next. Let us understand how to draw the ray diagrams for a concave mirror. This is a concave mirror. So this is the first law of reflection already we have discussed. When a light is incident making an angle I, it will get reflected back, making an angle R. Here I is equals to R. Next, when a light is incident passing through the center of curvature, this is the incident light. The light will get reflected back, passing through the same path in which the incident light is passing. This is a rule 1. What is rule 2? Already we have discussed this rule. When a light is incident with an angle I, it will get reflected with R. I is equals to R here. I think this is clear for you. What is rule 3? This is a rule 3. I mean, for example, there is a mirror like this. When a light is incident parallel to the principal axis, when a light is incident parallel to the principal axis, this is a focus. This light will get a passing, reflected back, passing through the focus. You can incident n number of lines passing. This is the principal axis. This is the focus. See here, it is passing through the focus again. This is the rule 3. With the help of these rules, we can draw the ray diagrams. I already took some ray diagrams here. See here. Here an object is kept at infinite. Well, like the light rays are parallel means it is coming from infinite, very large object. So all the lights after hitting the reflecting surface, all of them are converging at that point. That is called image. Yeah, at the focus the image is formed. So this is first diagram, first ray diagram. The second ray diagram is the object is moved little bit closer to the mirror. That means object is kept beyond the center of curvature. So a light is incident parallel to the principal axis, touching the object. Another light is an incident passing through the center of curvature. See, when a light is incident parallel to the principal axis, how it would get reflected back? Passing through the focus. See here, passing through the focus. So this incident ray, the reflected ray. This is a reflected ray. These two reflected rays are meeting at this point. If you draw a line perpendicular to the principal axis, so here you will get the image. This is diagram 2. This is diagram 3. Now I will get this object very closer to the center of curvature. That means I will get at its center of curvature. So where the image is found? Again at the center of curvature. So this is a diagram 3. And if I move this object between F and C, see here I kept an object between F and C, where I am getting the image? Beyond center of curvature. This is a diagram 4. The fourth diagram is when I keep an object at focus. Where the image I will get? At the infinite I am getting the image. See, when I get an object between F and C, F and P, I am getting an image on the other side of the mirror, back side of the mirror. So this is a virtual image we call it as. In this case, in the case 6 only we get the virtual image. In all the cases you will get a real image. So let us understand it like this. Like this. Here I have given some see in this table you can understand when an object is at infinite where the image is formed at the focus. Highly diminished image, real and inverted image. When an object is kept beyond focus, the image is formed between F and C, and diminished image is formed. Here it is highly diminished, here it is diminished, real and inverted image. Again, when an object is kept at C, the image is also formed at C. Same size of image is formed, real and inverted image is formed. When an object is kept between F and C, you are getting a image formed at beyond C, enlarged image is formed, inverted and real image is formed. When an object is kept at F and a very small size of image, you are getting an image, a very small size of object, you are getting an very big enlarged image, so highly enlarged image that is formed at infinite, that is real and inverted image is formed. When an object is kept at between F and P, enlarged image is formed, virtual and real image, virtual and erected image is formed. This is a special case. So you have to understand like this. See, this is a very important point. Let me explain. When I am getting an object very closer to the mirror, object when I am getting very closer to the mirror, is that not the image size is increasing? When I am getting an object very closer to the mirror, see in this case, here it is size of the object is at infinite. Here when I am getting very closer to the mirror, see size of the image is increasing. Here very enlarged, here diminished, largely diminished, same size of image is formed, enlarged image is formed, Very enlarged image is formed, enlarged image is formed, but it is a virtual image. Clear? I could explain, I can I could be able to explain these concepts only in 6 minutes. That is very difficult. But when we discuss the top, when we go into the topic, we'll discuss in all these concepts in depth. This is clear. I'm stopping here.